Hi, I want to have us review what a least common multiple is, also known as an LCM. So, when we're talking about a least common multiple, let's first start with numbers. To have a least common multiple with numbers, it has to be the smallest multiple that the numbers have in common. So what do I mean by that? Well, let's take a look at an example. Say I wanted to know what the LCM of 5 and 4 was. All right, so in order for us to figure out that least common multiple, I'm going to start by listing off all the multiples of 5. Well, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, and so on and so forth. If I look at all of the multiples of 4, well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. Notice that I can stop there because I see that both my list of numbers for 5 and my list of numbers for 4 have a number in common now. They didn't before, but once we got to that number 20, they now have something in common. So that means that my least common multiple would be 20. So it's the first number that both of those have in common. Well, let's say we are dealing with variables. If you're dealing with the same variable, then we want to take the biggest exponent. So let's look at if I have x and I have an x to the third power. Okay, similarly to what we just did with the numbers, let's think about this. If it's x, it's really x to the first power if I think about it with exponents. So I'm going to keep the base the same, but just like what I did with those numbers above, I'm going to start listing all the multiples of that exponent. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. So notice that I have an x to the first, an x squared, an x to the third, an x to the fourth. If I think about all of my variables, x to the third. So once again, I'm going to keep it as an x to the third because that's the first multiple of x to the third. So then now I'm using the exponent, and now 3 times 2 is 6. 3 times 3 is 9, and so on and so forth. Notice when I start looking at that list, the first thing that they have in common was an x to the third. Because once again, between that exponent of a 1 and an exponent of a 3, we had to take the bigger exponent. So our least common multiple was x to the third. What if we have either different variables or terms? If that's the case, then what we're going to do is we're going to multiply them together. So say I wanted to know what the least common multiple of x and then x minus 6 was. Well, notice that x is a monomial. It's one term. There's no addition or subtraction signs. X minus 6 is a binomial. If you want, you can put it in parentheses. That is very different than an x. Okay, monomials and binomials are very different. So like it states, what we do to find the least common multiple is we just multiply them together. So x times x minus 6. Now I'm not going to distribute. I'm going to leave it like that multiplication. This would be my least common multiple. Another quick example, if I have different terms. Notice that if I have an x minus 7 and an x plus 5, and I wanted to know what the least common multiple was, well, once again, x minus 7, I can put it in parentheses. It is a binomial. X plus 5, I could put that in parentheses. That's a binomial. But notice that they are two very different binomials. So because they are very different, our least common multiple would be us just multiplying them together. So notice that x minus 7 times x plus 5 would end up being that least common multiple.